Alright guys, so we're here in 3-2. We got a warm-up. You know the drill, so take a moment, write down these 4 questions with the picture, and pause the video, and we'll go over it here in just a second. Alright, so to get started, we got the quick warm-up here. So number 1, we're identifying each angle pair. So we're naming what kind of angle it is. So starting off with angles 1 and 3. So we got 1 and 3. So you got to first make sure you identify the transversal. So in this case, this is our transversal. See how it's going through this set and this set of lines. And when you look at each set of 4 angles, 1 and 3 are both at top left, so that means they are corresponding. Number 2, it says we angle 3 and 6. So here we have angle 3. It's not showing up there, so let me fix that. So we have angle 3 and angle 6. The second part to this problem is you need to recognize that this is the interior. Let's do a point there, interior. And these angles are on the exterior. So as you look at these 2 angles, they're both on the interior, but they're on opposite sides of the transversal. So these are going to be then alternate interior angles. Just like these are corresponding angles. They're all angles, obviously. Alright, so number 2 should have been alternate interior. You also, just so you know, you can call this AIA, because that's, you can just tell what it means. It's an acronym for alternate interior angles, and that's fine. Number 3, we had angles 4 and 5. So I'll go ahead and erase that. So now we're looking at angles 4 and angle 5. And again, you'll see these are both on the exterior. Okay, so they're both on the exterior, but you'll see that they're on opposite sides of the transversal. So this is going to be now alternate again, but they are exterior angles. You can call these AEA, alternate exterior angles. And finally, we have angles 6 and 7. So 6 and 7, if you look closely, get that cleared off. This one, we're looking at again 6 and 7. So 6 and 7, they're both on the interior, and they're on not alternate sides, they're on the same side of the transversal. They're both on the bottom. So these would be same side interior angles. So in this case, you know, same side interior, and that's fine. Okay, so there's our warm-up. Again, we're going to be doing theorems in lesson 3.2 using these angles, talking about which ones are parallel in specific situations, or not which ones are parallel, which ones are congruent in specific situations. If you can't guess what that situation is when 2 of the lines are parallel. Kind of gave that away, but we need to know those names so we know which theorem we're applying. So that's what we'll do as we move forward here. So getting into 3.2. Understand the objective for today. We are going to prove some theorems, and we're going to use those theorems. We're going to prove and use theorems about angles formed by parallel lines, and that's kind of what I was just telling you about a minute ago. We have parallel lines. I like that phrase. Anyway, and a transversal. So that's going to be the big difference, is that our lines in this section are going to be parallel. Still using the same vocabulary from 3.1, but we have, again, parallel lines as we go through 3.2. And that's how these theorems are going to need to be formed. So before we get into the theorems, there's a postulate. You are going to need to know the difference between which one is the postulate and which ones are the theorems. So the first one, and these are going to be used quite a bit in chapter 3, so you definitely want to know these theorems. They are foundational theorems. So the first one is going to be your corresponding angles postulate. Again, make sure you write this down in your postulate sheet. And again, it is a postulate. And it says that if and if two parallel lines, that's the key on this, and all these theorems we're doing in 3-2, we're going to be dealing with parallel lines. So two parallel lines are cut by a transversal. You see T here is the transversal. Then the pair of corresponding angles are going to be congruent. So you see that there's 4 pairs of corresponding angles. So we have, again, 1 and 3, so they're top left, they're congruent. And then 2 and 4, top right are congruent, and so on and so on. Okay. You wonder how is this a postulate? Well, it's really easy to prove. All I'd have to do is take this line and slide it over, and it would perfectly match up with line P. I wouldn't have to actually go through a proof. I can just slide this line over, and it would line up with line P because they're parallel. Therefore, 3 and 1 would be on top of each other. 2 and 4 would be on top of each other, and the same for 5 and 7 and 6 and 8. So it's really easy to kind of show you that this is a true statement, or it is a true hypothesis and conclusion, which makes it a postulate. You don't really have to go through a full-fledged proof to prove this one out. So make sure we have that written down. You're going to need it. Alright, so there's going to be some questions here that involve proofs, obviously, but there are going to be some algebraic concept 1 as well. So just like in chapter 1, we had some algebra problems that came off of these properties and theorems and postulates, we're going to have the same thing here. So example 1, we're going to use that corresponding angles postulate, and you need to realize if we're solving for angles, if they're corresponding, then we can set them equal. Okay, so in this case, if we were going to solve this out, and again, you can pause this if you need to get this written down, what you should realize is that we have 2 angles right here and right here that are corresponding. Regardless of what they're asking you to find here, you're probably going to need to find x. So before I even really read this question, I'm going to go ahead and write up an equation here using the corresponding angles postulate. So I'm going to say 4x plus 22 equals 5x. And I'm doing that because corresponding angles are congruent. And because they're congruent, it means I can set their measures equal to each other. So this is really easy to solve. You just subtract 4x from both sides. So those will cancel, and you'll get 22 equals x. So now I know that x is 22, which means I can find those angles. So you can use 5x for your angle. Remember, these are equal to each other, so it doesn't matter which one you find, they're going to equal the same thing. So I'll go 5 times 22. You can just go 22 times 5 if you want to multiply it out. 5 times 2 is 10. That's 10, 11, so 110. So that's going to equal 110 degrees. So what we've done is I set these 2 angles equal to each other, solved for x, got 22, and I plugged x into this angle right here. I got 110 degrees. And because these angles are equal, I now know that this angle is also 110 degrees. There is another way to kind of figure this one out, is if you didn't see it already. Those 2 angles right there formed a linear pair, so using the linear pair postulate, or if you want to use linear pair theorem, based on what the book is saying, called the postulate. But those 2 angles would add up to 180. So if they add up to 180, you wouldn't even have to solve this, right? You would just know that 110 plus 70 is 180. However, if that angle was gone, which it very likely could be, you're going to have to solve the equation to solve this one out. So make sure you know how to do that. Anyway, at this point, we want the measure of angle ECF. So you got ECF. So I'm looking at this angle right here. Okay, so we do, however, have this 70-degree angle, and notice it's bottom right. This is bottom right. So by default, that's a corresponding angle, which makes it 70 degrees, and we got it. 70 degrees, done. Next, DCE. We have DCE. I already found that one, is 110. Plug that in. Alright, so that's using corresponding angles to solve problems algebraically. There are other theorems though. Last thing, and then we're going to go into all those other theorems. This is one you can kind of work out yourself. there's really not much to do. Like if you know corresponding angles, hopefully you can just know what x is. See how these are this line coming across here is a transversal. These two lines here, which are parallel, are our parallel lines. So these are corresponding angles, and because these lines are parallel, we can say that they are congruent. So x is 118. Alright, that's pretty simple. Just another example to throw out there. Okay. Alright, so one last thing, and I'll draw a picture of this one because this does come up from time to time. So if you have a transversal and it's perpendicular to two parallel lines, so let's say I had two lines, again, that were parallel, and then my transversal, I should draw that a little bit better. I'll try at least. And your transversal came down and formed a right angle. So you just saw that right angle. Well, then that means all the angles have to be congruent. When I say congruent, they're all going to equal 90 degrees. This is a special case that you want to write down so that you have it. So again, if I use corresponding angles, I know those are 90 degrees. Top right, top right. But a straight line is also 180 degrees, so that would mean 90 plus 90. So 90 plus 90 is 180, and then same thing here, 90 and 90 is 180, and same here, right? So again, we have 90 across the board, which means we have all the same here because of corresponding angles. So again, if you have one 90-degree angle, you know them all, and you don't really have to solve anything at that point. Okay, so when that pops up, you should be ready to go. Alright, so again, we did a postulate at this point, so I didn't have to prove it. However, there are other concepts that are attached to the parallel line transversal scenario, and they're going to be all theorems. I'm only going to prove one of them. However, all the theorems are fairly similar in the way that they're proved. So just make sure you're aware of that as we go through the one proof that we are going to work through, in case I gave you another one either as a homework assignment or a quiz question. Make sure you understand how to do this proof, and then you should be able to do the others. Okay, so these are the theorems, so make sure you know them by heart. I can give you an easy way to kind of remember them, but make sure you write them down first, and then again, pause the video while you do it, and then I'll go ahead and show you my little shortcut. Alright, so here's the shortcut. I'm going to draw two big old parallel lines and a transversal. And I'm going to label my angles as my big angles, and then I'm going to have my small angles, which I'll call S. Now here's the little trick that I like to use. I always say the following. I say a big angle is equal to all the other big angles. So if it's obtuse, which is big, they're all equal. You have a small angle, it's equal to all the other small angles. So again, all my small angles are going to be equal to each other. And that can involve multiple theorems. And then finally, if you have a big angle plus a small angle, it's going to equal 180 degrees. Again, it doesn't matter which ones you use. I can just pick a small one from there and a big one from over there. I know they're going to add up to 180. Doesn't matter where they come from. You can just use substitution in that case to get there. Now, one thing that they will try to do from time to time, and it's something you're going to need to be aware of, is they're going to attempt, let's try to do that. They're going to attempt to add an extra line in here. It's an ugly line. I just kind of get the point. And it's like adding a second transversal, but you need to realize in those cases still that here's my big angle and there's my other big angle. Even though I got this transversal in there, you got to, in a way, pretend it's not there, and you can still see that those two angles are congruent because they're formed by the same transversal. Just because there's another transversal doesn't mean that angle's gone away, it just got broken up into two pieces. Okay? So you are going to see that. Make sure you're aware of it when that time comes. Alright. We're going to go through a theorem now. The theorem we're going to hit up is going to be the alternate interior angle theorem. So in this case, we're going to set up our T-chart. Again, take a minute to get this written down as I'm writing it as well. You can pause if you need to. We got our statements and we got our reasons. Step 1 is going to be L is parallel to M, and that's given. Okay. So as you look at these angles, we have some properties that we could apply, and all you really need to do is just look at the picture and say, well, what do I know? And I know just by looking at it. And again, you could say, well, I know that angle 2 and 3 are congruent. Well, you do because you know the alternate interior angle theorem. However, we can't use that. So let's use other properties that we know. And some things you may want to add to your reasoning sheet are going to be the following. This guy, the vertical angle theorem, is going to be used a lot. Okay? And as we go through our reasonings here, we are going to end up using the corresponding angle postulate, alternate interior angle theorem. I mean, we're proving it right now, but after we've done this proof, you can use it. The alternate exterior angle theorem, same side interior. We're going to use all these theorems to solve these problems. So we need to make sure we write that in our list. The ones we're going to use for this proof are going to be the vertical angle theorem and the corresponding angles postulate. So you look at what we have. I know that angle 1 and angle 3 are congruent. So I'm going to write that out. Angle 1 is congruent to angle 3, and that's by the corresponding angles postulate. Okay, we can use the postulates at this point. We learned it right before the alternate interior angle theorem, so we can use it. And another one we used a while ago was angle 1 and angle 2 are congruent because they're vertical angles. Again, you look at your picture and say, well, what can I label? Well, you can label that. So I'll say angle 1 is congruent to angle 2. So that's going to be the vertical angle theorem. So now that you look at these, you'll see that they both have angle 1 inside of it. You could have also written it this, flip this one around. You don't have to, I'm just trying to show the property here. For corresponding angles, I could have written angle 3 is congruent to angle 1, and you can see transitive a little bit easier, but we can use the transitive property here to do our last statement. We can say angle 2 or angle 3 is congruent to angle 2, which is the transitive property of congruence. And because of the way I have it written out, you could flip this around to get, you need the exact proof statement. You could have written the proof a little differently than me so that you wouldn't need this extra step, but based off the way I have it written, I do need to flip it around. So I'm going to go angle 2 is congruent to angle 3, and that's your symmetric property of congruence. Again, at that point, obviously, like I said, I could have made this one step shorter if I did vertical angles first and then corresponding angles and kind of thought ahead a little bit more. But at that point, when I'm at step 4, again, it's easier just to write step 5 than to erase all those steps and try to fix it, because it's not that big a deal to flip the two angles around. So I just went ahead and did that just because it was just less work at that point. Okay, so obviously, like I said, you could have done that in 4 steps based on how you write it, but there's nothing wrong with the way I did it here. Okay, again, make sure in your sheet here you write all these reasons down for your chapter 3 proof reasons, and you should you'll find yourself using them quite a bit. All right, at this point, again, we're going to do some more algebra using the different properties that we've learned so far. So in this case, we're going to go ahead and solve for x. There's a couple angles that we have with x's in them, and you can kind of set them up any way you want. I'm going to try to show you a couple different equations that you could use. So I could look at this angle here, which, by the way, that's a big angle, and I can look at this angle right here, which, as you look closely, is a small angle. So if I looked at these two, you could go x plus 2x minus 135 equals 180. So that would work as an equation. Also, look here, I got my small angle right here, and I got another small angle. These are corresponding, you could also go 2x minus 135 equals x minus 30. Nothing wrong with that. Also, because of vertical angles, you could say this: 2x minus 135 equals 75. So all these are equations that you could set up. There's some other ones you can kind of mess with, but again, it doesn't matter which one you use in the end. So I'm going to go ahead and solve this first one, and I'll solve the last one. I mean, they're all going to give you the same answer. So here I'm going to go ahead and combine like terms. Don't worry about these parentheses here, because there's nothing really to add or subtract in the parentheses. So x plus 2x, that's going to give you, I'll change the color here. That's going to give you 3x minus 135 equals 180. So if I'm solving this, I'm going to add 135 to both sides. And I now have 3x equals, and that's going to be, let's see, 5, 8, 9, 10, 11, and that's 315. Okay, at this point, I'm going to now divide by 3. If you don't remember how to do that, I'm going to go 315 divided by 3. So 3 goes into 3 one time, and you subtract that, and you get 0 and 1. 3 does not go into 1, so you put 0, and then pull down your 5. And 3 goes into 15 5 times. So I get x equals 105. So again, that's the same for, it should be the same answer you get no matter what. I'm going to come down here and I will do this one right here on the bottom, and I should get the same answer. So here I'm going to add 135 to both sides. If you happen to hear a baby crying in the background, that's my daughter. She's trying to go to bed, so don't mind that. Anyway, so I'm going to add 135 to both sides, so I get 2x equals, here I'm going to add 75 and 135, so that's going to be 5 plus 5 is 0. Carry the 1, so that's 10, 11. And then carry the 1 here, and I get 210. Okay, divide by 2, and x equals 105. Alright, so again, I'm just letting you know it doesn't matter how you set it up. I'm not going to do it a third time because it gets kind of old. You're going to get the same value for x. So once you know that, I already know this angle is 105, and I already know that this angle here is, oops, I shouldn't say 105, I kind of did that backwards, my bad. Sorry, this angle is going to be 75, and this angle here, which is x, is 105. So I know my big angles, all my big angles are 105, and all my small angles are 75. So it doesn't matter which one we're trying to find, we got it. There are some other quicker ways to solve this too. You could have just found, okay, this is a big angle right here. You could have gone 180 minus 75. I'm just trying to show you all the different ways. You know, so that's the third way. That would have been the quickest in this case. I just want to make sure you know how to do the equations. Or kind of these examples are giving you almost too much information, so you have so many options. But I'm using that as an advantage to show you the different ways to solve for x. Okay. So anyway, EDG. That's EDG. Notice that's a small angle right here. We know our small angles are 75 degrees. So that's the measure of angle EDG. Next up, we have BDG. That's BDG. Follow me here. That's a big angle. I already have it as 105. So 105 degrees. Again, that problem can be solved rather quickly. I'm kind of going through it the long way because I want to show you all the different avenues that you could approach this problem with based on what information you would actually be given. Okay, final example here. You're going to find the measures of the acute angles in the diagram. So what you'll notice on this one is we actually have two transversals. So they are two different sets of problems. This is, again, transversal 1, and this is transversal 2. Here, there's two of them. So in this first one, we got our big angle, and I'm going to try to color code this. So what I'll do, I'm going to do the first one, and let's do it in red. So we got this angle right here. That's our big angle. So I'm going to try to show you my quick way. So our big angle equals 125. The small angle then is going to have to be 180 minus 125. So we're just going to subtract that. So that's 70, 60, 55 degrees. It's going to be your acute angles on all of these parallel lines. Again, even though you have 3 parallel lines, it's all the same as long as it's on the same transversal. So that would be 105. And I'm going to go ahead and do the second set of angles, and you'll see this one, our big angle, is going to be 120. So if your big angle equals 120, then your small angle would be 180 minus 120. So in this case, that's going to be 60 degrees. So here we have 60, 60, and 60. So again, I've approached this in a lot of different ways. They're trying to get you to see, in this case, that 25x plus 5y equals 125. And they're trying to show you that 120 equals 25x plus 4y. I showed you there's a shorter way based on the information that you're given. However, because of the way this is set up, this does go over an important thing that you will need to use at some point, and that's solving systems of equations. So I'm going to show you the system of equations method for solving this problem. And please write this one down. Just because this example is able to show you the shortcut does not mean you're going to be able to do that every time. Again, these examples give you more information than you really need to have, and that's why we have multiple ways of solving it. So if we're going to do systems of equations, this is what it would look like. We're going to have 25x plus 5y, and because that's a big angle and a big angle, these are both equal, so it would equal 125. That would be equation 1. Equation 2, I'm going to look down here, we have a big angle and a big angle again, so I have 25x plus 4y equals 120. So in this case we have 2 systems of equations. They are already stacked, and I'm going to use what's called the elimination method. So I'm going to subtract the 2 equations. If you subtract these 2 equations, the reason why I'm doing that is it's going to cancel out or eliminate a variable. Because I had 25 and 25, subtracting will allow that to happen. Here I go 5 minus 4, and I get 1y. And here I go 125 minus 120, and you get y equals 5. If you know what y is, I can use equation 1, I don't care, and I can plug that back into my equation to find x. 25x plus 5 times 5 is 25. That's going to equal 125, and we can solve this for x. So subtract 25 from both sides. So 25x equals 100, and finally divide by 25, and x equals 4. So if you have these, if you have these angles, you can easily solve for x or y. Now you notice here it's not really going to do much because we're looking for the acute angles, and if I have the obtuse angle, I can get the acute. But I want to make sure you know how to solve these, because you will find yourself using them in this chapter. So this is elimination method, and we can go over some substitution ones in class as well. Okay, like I said, once I have this, I would plug it in. This obviously would give you 120 if you plugged in x and y, and obviously here, because that's 125, if you plugged in x and y, you're going to get 125 as well. But like I said, it doesn't really help you in this problem, but I want you to see an example of me doing system equations, and make sure you're aware that they will get used. So if you have a situation where there's 2 variables, then that, as you're trying to solve these algebraic ones, set up 2 equations. You're going to need to use a system of equations to solve it. I want to make sure you're aware of that now. Alright. So again, we got a quick lesson quiz that goes with this lesson, so make sure you work through just 1 through 4. It goes fairly quick. So make sure you do that and pause and do it. And then when you're done, do not forget to do your reflections. So make sure you do a reflection either for Mr. Patrick for me or Mrs. Moore. again, hopefully I got a filter on this mic. Hopefully you weren't picking up too much of my daughter crying. But I'm not re-recording this because of that, so I just figured deal with it, right? So anyway, go ahead and get started on the lesson quiz, and good luck.